All right, welcome to the deep dive. Today we're going to be looking at something pretty cool in the LangChain world, LangGraph.
Yes.
You can think of it as a way to really build out really sophisticated AI applications. You know, the kind that have all kinds of moving parts, maybe different AI agents working together.
Yeah, exactly. It's for those of you who, you're curious about what's going on behind the scenes of those advanced AI systems, the ones that can have these really complex conversations or seem to reason through tough problems. LangGraph lets you peek under the hood a little bit. It's
Mhm.
all about building these intelligent workflows that go way beyond just simple, like you ask a question, you get an answer kind of interactions.
Right, right. And we've got a really fascinating set of materials here. They introduce LangGraph, obviously. They explain the basic ideas behind it. They even show us uh, how you can visualize these AI processes. And we even have some code examples to really bring it all to life.
Yeah.
And our goal today is to really dig into LangGraph, understand what makes it tick, why it's generating all this buzz,
Mm.
and uh, and how it can help us create more powerful and adaptable AI.
Right.
So, okay, let's start unpacking this thing. What is the big challenge that LangGraph is designed to solve?
Well, as AI applications just get more and more advanced, the traditional ways we organize them, they just start to break down. They're not quite enough.
Yeah,
Our sources here point out that when you have these really complicated workflows with lots of steps, the old ways of representing them, it becomes a bottleneck.
I see. I see. It's like trying to, navigate a huge modern city, but you're using a map from like the 1800s or something.
Exactly. It doesn't work. It doesn't cut it. And that's where LangGraph comes in, right? It builds on what LangChain has already done.
That's right. That's right. LangChain's expression language, or LCEL, it's essentially the language within LangChain that lets you define these, step-by-step workflows.
And it's great for setting up these linear processes, what are called directed acyclic graphs, or DAGs for
Oh,
short.
yeah. Yeah. DAGs.
You can think of a DAG kind of like an assembly line in a factory.
Okay.
One station does its job, then the product moves on to the next station, and so on. It's a fixed sequence.
Okay.
But LangGraph, it takes it a step further. It goes from these assembly lines to what we call cyclical graphs.
Cyclical graph.
And this might sound a little technical, but it's really, really important. It lets us have these um, more complex and iterative interactions. And that's really what's at the heart of how AI reasons in a sophisticated way.
I see. So instead of just going from A to B to C,
Hmm.
you can sort of loop back, revisit earlier steps, and even change things based on what's already happened.
That's a great way to put it. That's exactly right.
It's almost like a feedback loop for AI.
Yeah, you can think of it that way. And what's also interesting is that LangGraph operates at a bit of a lower level of abstraction compared to some other tools you might have heard of, like Crew AI, for example.
Yeah.
And that might sound like it makes things more complex at first, but it actually gives developers a lot more control. They can really customize their solutions.
Okay.
So if you're building a very specialized AI application with very specific needs, this granular control is really, really valuable.
I see. So this change from linear DAGs to these cyclical graphs. Can you break that down a little bit more? Why is that such a big deal?
Well, think about it this way. A DAG, that assembly line we talked about, it works well when you have a task with a clear beginning, a middle, and an end. Each step is only done once.
Right.
But when you're working with an advanced AI agent that needs to learn and refine its approach as it goes along, maybe even rethink a decision based on new information, a rigid one-way structure, it just doesn't work.
Right.
Cyclical graphs, on the other hand, they allow for these feedback loops. An agent can do a task, look at the results, and then go back and change its strategy. This lets us do things like recursive tasks, where a task can even call on itself, and it lets us make adjustments in real time based on how the system's changing.
That's pretty cool.
Yeah, it's like the difference between following a set of printed directions and having a GPS that reroutes you based on traffic.
Oh, yeah, yeah. Okay. That makes a lot of sense.
Right.
So it's about making the AI much more adaptable and responsive, which is, closer to how we humans solve problems.
Right.
We often have to backtrack, rethink things or try something completely different.
Absolutely.
Now, our sources break down LangGraph's architecture into three main pillars.
Okay.
So let's go through those one by one, starting with the graph structure itself.
Right.
What's the basic idea there?
Okay. So at its core, LangGraph uses this graph-based model. You've got nodes that represent individual AI agents or actions, and then you have edges that connect them.
Okay.
But it's It's more than just a simple flowchart.
Right.
The real power is that it allows for all sorts of branching paths. You can have conditional logic. So if this happens, go this way, otherwise go that way.
Right.
You can even have loops in the workflow. And the edges themselves, they're not just simple connections.
Right.
You can set up specific conditions that need to be met for an edge to be active, or even filter the information that goes from one node to another.
Oh.
And maybe the most important thing is that this graph structure gives us a really clear visual representation of the entire AI workflow. You can see what's going on.
Okay. So the visualization part.
Yes.
That makes sense. Being able to see these complex AI systems,
Yeah.
that has to be super helpful, for understanding how they work and figuring out what to do when things go wrong.
Exactly.
So that actually brings us to the second pillar, which is state management.
Okay.
And our sources, they really emphasize this as a key feature of LangGraph.
Right.
So why is that? Why is state management so important?
Well, state management is crucial, especially when you have these multi-step workflows that can be cyclical, like we were talking about. Think about having a conversation with an AI assistant.
Nope.
It needs to remember what you said earlier to give you good responses later on, right?
Right.
That's basically what state management is all about. LangGraph has this built-in system, it's automatic, and it takes care of keeping track of the context throughout the entire interaction.
Okay.
So agents can change their behavior based on new information or what happened before.
Yeah.
It makes sure the AI doesn't forget parts of the task or the conversation, and it even helps with error handling. So you can set up backup plans if something goes wrong at some point.
Yeah, that's great.
It's all about keeping things organized and consistent, like having a well-organized notebook for a complicated project.
That makes perfect sense. I mean, it sounds like that's essential for building AI that can actually handle, the messiness of the real world.
Yeah, definitely.
All right. And finally, we have the coordination mechanism. What does that do in the whole LangGraph system?
So when you have multiple AI agents working together, you need a way to coordinate their activities to make sure everything happens in the right order.
Right.
And that's what the coordination mechanism does. It makes sure tasks are carried out in the right sequence, whether that's one after another at the same time or even a mix of both.
Okay.
It manages the conditional branching we talked about earlier, so the workflow can dynamically decide what to do next based on what just happened.
Yeah.
It handles those cycles, those loops, making sure they don't get stuck and run forever. And it can even schedule tasks for specific times or, run things in the background.
So it's really like the conductor of an orchestra, keeping everything in sync.
Yeah, exactly. It's making sure every instrument plays its part at the right time, all working together.
All right. So we've got this really powerful framework. It's built on this flexible graph structure. It's got built-in state management and this sophisticated coordination mechanism.
Yeah.
Now, let's talk about making sense of it all, because it can get pretty complex, right? And our sources talk a lot about the importance of visualization.
Right.
So why is it so crucial to actually be able to see these AI workflows?
Well, when you're dealing with systems that have lots of agents and logic going on, it can be really hard to keep track of everything just in your head.
Yeah.
Visualization gives you that clarity. It lets developers see the entire flow of the application at a glance. They can see how the different parts are connected, and they can spot potential problems or areas that could be improved.
Right.
It's like having an X-ray vision into the AI system.
I like that.
And when things go wrong, which they always do in development, visualization becomes super important for debugging. You can see the path of execution, check the state of the system at different points, and pinpoint where the issue might be.
Right.
Imagine trying to fix a complicated electrical circuit without a diagram.
Oh, yeah. That would be a nightmare.
Yeah, visualization gives you that essential diagram for your AI workflows.
I see. And LangGraph actually has a specific tool for this, right? It's called Mermaid, I think.
Yes, that's right. It integrates with Mermaid, which is this great open source tool for creating diagrams.
Okay.
And it uses a really simple text-based syntax, so you don't have to be a graphic designer or anything.
Right.
With LangGraph, you can use methods like DrawMermaidApine to automatically generate visuals of your workflows. And these diagrams show the nodes, the agents, the edges, the flow of data, decision points, and even where the workflow starts and ends.
Okay.
And these visuals are super helpful for understanding the system yourself, but they're also great for documenting your work and explaining it to other people.
Right. So you can literally create a visual map of your AI system with a few lines of code.
Exactly.
That's amazing. And it's not just static diagrams either, right?
Right.
The source material mentions dynamic visualization as well. What is that about?
Yeah, so on top of the static blueprints, LangGraph also lets you see how the system's state changes while it's running.
Oh,
So
wow.
you can see in real time how the data's flowing, how decisions are being made, and how the context is being updated.
That's really cool.
Yeah, and this level of detail is really valuable for understanding those interaction patterns within your AI system and for fine-tuning its performance.
Right.
You can pinpoint where data might be getting stuck or where the logic might be going off track. It's like watching data packets move through a network in real time.
Yeah. That's a great analogy.
Yeah.
Okay, so we can see these workflows in these static diagrams and then also in these dynamic live views.
Right.
Let's move on to the practical side of managing these complex interactions, especially when you've got multiple AI agents involved.
Okay.
What are some of the main challenges there, and how does LangGraph help?
One of the biggest challenges with multi-agent systems is coordinating all these specialized agents.
Right.
You might have one agent that's really good at creating content, another one that's good at finding specific information, and another one that's great at summarizing text.
Yeah.
How do you make sure they all work together smoothly and efficiently towards a common goal? And LangGraph gives you a structured way to define these agents and set up clear communication channels between them.
Okay.
And it also lets you build in really good error handling.
Okay.
So if one agent runs into a problem, you can have backup strategies to make sure the whole system doesn't crash.
Right. So it's like having a backup generator if the power goes out.
Exactly. Exactly.
There's a great example in the source material about a code review system.
Okay.
Can you walk us through how LangGraph could be used for that?
Sure. Imagine you have a piece of code that needs a thorough review.
Okay.
With LangGraph, you could have different agents, each specializing in something different.
Okay.
So you could have a style agent that checks for, proper formatting and conventions.
Right.
You could have a security agent that looks for vulnerabilities, a performance agent that analyzes how efficient the code is, and maybe an architecture agent that looks at the overall design. And LangGraph would manage the whole process. It could send the code to the style agent first, then to the security agent, and so on.
Okay.
These agents could work one after another, building on each other's analysis, or they could even work at the same time to save time.
Right.
And if, let's say, the security agent finds a serious flaw, LangGraph could be set up to send the code back to the developer for fixes.
Oh.
So you get that iterative process we were talking about, and then in the end, all the results from all the different agents would be combined into a comprehensive report.
Wow. So it's like having a whole team of code review experts, each with their own specialty, all working together in a really organized way.
Exactly. It brings structure and efficiency to something that could easily become really messy and error-prone.
Yeah, for sure. And it's not just about coordinating these different agents, right?
Right.
LangGraph also supports conditional processing and routing, so the system can make decisions based on all sorts of factors.
That's right. LangGraph lets you design workflows that can change direction based on different conditions.
Okay.
This could be based on the user's input. For example, if someone asks a really technical question, it could be routed to a more specialized agent.
Right.
Or it could depend on the results from earlier steps. If one step produces a certain result, the workflow might branch off in a specific direction.
I see.
You can even use external factors or the overall state of the system to make these routing decisions. This flexibility is really powerful. It lets you handle a wide range of situations, from simple tasks to really complex and context-dependent operations.
So it's like having an AI system that can think on its feet and adjust its strategy as it goes.
Exactly. It's about making the AI more dynamic and responsive to the information it's receiving.
All right, let's get into some concrete examples to see how this all works in practice.
Okay,
The source material has a basic workflow example written in Python.
right.
Can you break down the key parts of that code for us?
Sure. So this example is meant to show the basic structure of a LangGraph application. It starts by defining a state. In this case, it's a Python dictionary that's used to store the messages that have been exchanged so far and the current step in the workflow.
Okay.
Then it defines two simple nodes as Python functions. These are called collectInfo and processInfo.
Okay.
The collectInfo function simulates the action of gathering some initial information and updating the state accordingly. It adds a message and then moves the workflow to the process step.
Okay.
Similarly, the processInfo function simulates processing that information, adds another message to the state, and moves the workflow towards the end.
Okay.
Now, the heart of the LangGraph application is the state graph. You create one of these, then you add your nodes, giving them names like collect and process.
Right.
Next, you define the edges that connect these nodes, showing the flow of execution. In this simple case, it just goes from collect to process.
Right.
Then you say that the collect node is the starting point and the process node is the ending point, and then you compile the whole workflow into an application that you can run.
So it's like defining the steps, connecting them, and then pressing the go button.
Yeah, exactly. And even though it's a simple example, it shows the fundamental building blocks of LangGraph.
Yeah.
Defining the state, creating those processing units as nodes, connecting them with edges, and then compiling it all into a runnable application.
All right, that's a really clear explanation of the basics. Now, the source also has a more advanced example using AI agents.
Okay.
What does that one show us?
So this example builds on that basic structure and shows how you can have multiple specialized AI agents working together.
Okay.
It also uses the state graph, but this time it defines several different analysis nodes, things like style for analyzing code style, security for doing security checks, performance for checking how efficient the code is, architecture for reviewing the software architecture, and then finally recommendations for generating those final suggestions based on all the analysis.
Right.
And then it connects these agents in a specific order, from style to security to performance to architecture, and finally to recommendations. Just like the basic example, it sets the style agent as the starting point and the recommendations agent as the ending point, and then it compiles this multi-agent workflow.
Right.
So you can see how LangGraph can be used to coordinate these specialized analyses where the output of one agent is used by the next one, and then they all contribute to a final, more comprehensive result. Just like that code review scenario we talked about.
Yeah, it's like having a team of experts working together, each doing their part to produce a really thorough analysis.
Exactly.
And the source also mentions, importantly, that for real-world applications, you'd need to have robust error handling and monitoring.
That's right. These examples are great for illustrating the concepts, but in a real production environment, you need to be prepared for things to go wrong.
Right.
So you need good error handling to gracefully handle those unexpected issues. You need detailed logging to track what the system's doing over time. And you need good debugging tools to help you find and fix any problems that come up.
All right, so we've seen how LangGraph works. We've seen some examples.
All right.
Let's wrap up by going over the key advantages that LangGraph offers over more traditional methods for building these kinds of complex AI applications.
Okay.
What are some of the things that make it stand out?
One of the biggest advantages is its stateful architecture.
Right.
That built-in state management we talked about, it lets you maintain context over multiple interactions.
Right.
And that's crucial for things like conversational AI and complex reasoning systems.
Makes sense.
Another major benefit is cyclical computation.
Okay.
By supporting those cycles in the workflow, LangGraph enables those iterative processes and feedback loops that you can't do with traditional linear DAGs.
Yeah.
This lets you create more natural and dynamic interactions where the AI can learn and adapt as it goes.
Right.
And finally, LangGraph provides dynamic adaptation.
Okay.
It can change how the workflow behaves based on what's happening in real time.
Yeah.
So you can create systems that are much more flexible and responsive to unexpected inputs and changing requirements.
So it's about making the AI more adaptable and resilient, which is essential in the real world.
Exactly. It bridges the gap between the theory of these large language models and the practical realities of building reliable and scalable AI solutions.
So putting it all together, LangGraph allows developers to build AI systems that are not only more complex, but also more robust and flexible, which is exactly what we need for these modern generative AI applications.
Absolutely. It gives you the tools you need to create AI that can handle the complexities and the unpredictability of the real world.
All right, well, this has been a really fascinating deep dive into LangGraph. We've covered the basic concepts, the architecture, the visualization capabilities, and we even saw some code examples to bring it all to life.
Yeah.
Hopefully you, the listener, now have a better understanding of how these cutting-edge AI applications are being built and the power that tools like LangGraph bring to the table.
Right.
Being able to visualize and control these complex processes is really key to unlocking the potential of AI, I think.
I agree. And it makes you think about, the bigger picture of what AI can do. When we have these tools that let us create these cyclical, dynamic workflows, what kind of amazing applications can we build? What new possibilities emerge when AI systems can reason and adapt in these really sophisticated ways? That's something worth thinking about.
Yeah, it's really exciting to think about the future of AI with these kinds of tools at our disposal.